Hello there. Today we're going to talk about quadratic functions. The graph of quadratic functions is a parabola. It's either going to open up or open down, because they're functions. You can have parabolas that open sideways, but they wouldn't be functions. So specifically today we're going to talk about quadratic functions. Let's think of the basic parabola y equals x squared. Well, what happens when I make y equals x squared into this new function f of x equals a times x minus h squared plus k? Well, we're having a transformation of my original parabola where the vertex of that parabola was at 0, 0. This vertex is going to be at hk. Why is that? Well, this h, remember, is going to move the function right by an amount h. And this k is going to move the function up by amount k. So the vertex is going to move right h or up k. And depending on the sign of h, you could actually be moving left if h were negative, and down if k were negative. But the point is, my vertex, so my origin, is going to be moving to hk. So that's the new origin of this function, which is considered in standard form. In addition, a, this number in front, determines the vertical stretch. Remember that? So this determines the vertical stretch. And a, if a is positive, then the parabola opens up. And if a is negative, the parabola opens down. X equals h, whatever the h value is, x equals h, is a vertical axis of symmetry. If I want to find the y-intercept for this function, I plug 0 in for x, and then I can find my y-intercept and solve for y. If I solve the equation f of x equals 0, then what I'm finding is my x-intercepts. So let's take an example. So suppose we have a quadratic function f of x equals 2 times x minus 1 squared minus 8. And I want to find the vertex, the y-intercept, and the x-intercepts. Y-intercept, it could be one x-intercept. X-intercepts of this function here. Well, first of all, the vertex we can rewrite out of here. Remember, it's hk. For y equals a times x minus h squared plus k. It's hk. So you take the opposite sign of this h, or whatever's here, and then k. So we take the opposite sign of this number. So we're going to have opposite sign of negative 1 is 1, negative 8. So that's my vertex. 1, negative 8. And the axis of symmetry is at x equals 1. Secondly, if I want the y-intercept, we plug in 0 for x. In other words, f of 0. What is f of 0? Well, let's calculate this out. F of 0 is 2 times 0 minus 1 squared minus 8. And if you calculate that out, 0 minus 1 is negative 1. Squared is 1. 2 times 1 is 2. So we get 2 minus 8 equals negative 6. So this is my y-intercept. So we have a y-intercept at negative 6 and a vertex at 1, negative 8. The next step is to find the x-intercept. And to find the x-intercept, we have to solve f of x equal to 0. So I'm going to erase this, and we're going to solve f of x equal to 0. Here's our function, 2 times x minus 1 squared minus 8. We just saw the vertex as 1, negative 8. The y-intercept is at negative 6. And we want to solve f of x equals to 0 to find the x-intercept. 2 times x minus 1 squared minus 8 equal to 0. So the first thing we're going to do is add this constant, add 8 to both sides. So we add 8 to both sides. So I have 2 times x minus 1 squared equals 8. The next thing is divide by this 2 in front here. Divide both sides by 2, so we end up with x minus 1 squared equals 4. And now, how do you get rid of this square? Well, we have to take the square root of both sides. So we're going to square root both sides. So the square root of x minus 1 squared, well, they undo each other, is x minus 1. And the square root of 4 is actually plus or minus 2. Plus or minus 2. And the final thing now is you add 1 to both sides. So we'll have x equal plus or minus 2 plus 1. So those are my x-intercepts. But plus or minus 2 plus 1, we can calculate that out. So my x-intercepts are x equal to, if it were minus 2 plus 1, minus 2 plus 1 is minus 1. And if it were plus 2 plus 1, that's 3. So my x-intercepts are negative 1 and 3. So now we have all this information. We have the y-intercept, the vertex, and the x-intercepts. Let's sketch a graph of this function. So here's the xy coordinate plane, and let's put in the things that we know. We know the vertex is at 1, negative 8. So 1, negative 8 is about down here. So that's the vertex. It's a minimum because a is greater than 0, a is positive. So this parabola opens up. We know the y-intercept is at negative 6, so it's going to hit the y-axis right there at negative 6. We have two x-intercepts at negative 1 and at 3. So negative 1, there's an x-intercept, and at 3, there's an x-intercept. So now it's a matter of joining up the points to get the parabola. So here's a graph of our quadratic function, 2 times x minus 1 squared minus 8. We notice we have the vertex at 1, negative 8, the y-intercept at negative 6, and the x-intercepts at negative 1 and 3. Now what happens if you're not given a function in this nice form where I could just read off the vertex? What happens if you're given the equation of the quadratic function in this form, ax squared plus bx plus c form, which is generally the types of quadratic functions we will see more often? How do you find the vertex when you're given a quadratic function in this form, and how do you find the zeros?